Hello students, in this lecture I am going to discuss about 8086 bus cycle in minimum mode. So in case of 8086 microprocessor, there is no concept of machine cycle as we have heard about the machine cycles in 8085 microprocessor. So in 8086 microprocessor there is no concept of machine cycle and it is no longer applicable also. So this concept is not applicable for this 8086 microprocessor. So the execution unit of 8086 microprocessor executes instructions in certain clock periods. These clock cycles do not constitute any form of machine cycles. The bus interface unit of the microprocessor fetches instructions and operands from the memory, and any external access either to the memory or input-output device requires 4 clock periods. So this group of 4 clock periods is called bus cycle. As you can see here, we need only 4, this microprocessor 8086 microprocessor need only 4 clock cycles for accessing either to the memory or input output device. So there are memory input output read bus cycle or memory or input output write bus cycle. So one bus cycle consists of 4 clock cycles, 4 T states, or 4 clock cycles. What happens here, 20 bits, as I've told you, the address of 8086 microprocessor, the address bus is of 20 bit. So 20 bit address is sent on the address bus AD0 to AD15 and A16 to A19. So the 20 bit address bus is being carried out by this address bus. So AD0 to AD15 carry 16 LSBs of the address and A16 to A19 carry 4 MSBs of the address. As you can see here, I have drawn the lines to be in this way, means and the depending upon the address, the value of A0 to A15 can be anything. So I have drawn it like this, showing whether it is high, low, depending upon the address. Similarly, the lines A16 to A19 has been drawn in this way, showing anything can be the status of A16 to A19 depending upon the address. Now the address remains on the address lines only during T1, that is T1 clock cycle, because these lines operate in multiplexed mode. AD0 to AD15 lines remain in high impedance state. You can see this is high impedance state during the clock cycle T2. The time interval T2 is used primarily for changing the direction of the bus during read operations. During T3 and T4, data are transmitted on this AD0 to AD15. Again, for data I have shown it to be like this because data can be that is D0 to D15. The status of D0 up to D15 can be anything depending upon the data that is being transferred. So I have not shown particularly high or low, it can be any status. Now the ready signal is sampled during T3 clock cycle. The slower peripheral devices use this signal to indicate that the device is not ready to send the desired data within specified time. In the event that a not ready indication is given by the slower peripheral device, wait states are inserted between T2 and T3 clock periods to give enough access for the slower peripheral device. Each wait state is of same duration as a clock cycle. It is of the same duration of a clock cycle. During a wait state, the signals on the buses remain the same as they were at the start of the wait state. If the ready input is made high during wait state, then after wait state, the 8086 microprocessor will go on with the regular T4, that is T4 clock cycle. So however, if the 8086 if the 8086 ready input is still low at the end of a wait state, then the 8086 microprocessor will insert another wait state. The 8086 microprocessor will keep on continuing will keep on inserting wait states until the ready input is made high again. So during T2, T3 and T4, status signals S3, S4, S5 and S6 are carried by A16 to A19 lines. You can see here the S3, S4, S5 and S6 are being carried by these lines. That is, I've always written that A16 to A19 slash S3, S4, S5, S6. You can see the pin configuration also. It can work as both the lines, either address lines or status lines. So during the first clock cycle, it will work as address lines. During the rest of the clock cycle, it will work as status lines. The ALE signal goes high during the T1, that is T1 clock cycle, to latch the address latch the address into the external latch, that is this multiplexed address. To demultiplex this address data lines, this ALE signal goes high. Now Mn/mx bar, since I am talking about the bus cycle in minimum mode, so Mn/mx bar is also high, indicating that the CPU is operating in the minimum mode. M/IO bar is high, means, since I am talking about memory read cycle, means the address is for memory. It indicates that the address sent by the microprocessor is for memory. RD bar signal goes low. Here as you can see, the RD bar signal goes low during T2 clock cycle. So when it goes low, data can be read by the CPU. It goes again high in the T4 clock cycle. You can see it is going high again in the T4 clock cycle. DT by R bar goes low during T1 clock cycle, thereby showing that the microprocessor is going to receive the data. DEN bar signal goes low during T2 clock cycle, and again it becomes high during the T4 clock cycle. So what DEN bar signal, as I have told you, what is the purpose of DEN bar signal? It informs the transceiver that CPU is ready to send or receive data. So once the address reaches the memory, then microprocessor makes the DEN bar signal low in the T2 clock cycle, during the T2 clock cycle, to tell the memory that it is ready to receive the data. So this was all about, I have discussed all the pins here. So this was all about memory read cycle of 8086 microprocessor. Now this is the memory write cycle for 8086 microprocessor in the minimum mode. Everything is going to be same, AD0 to AD15, A16 to A19, then Mn/mx bar, M/IO bar, ALE, BHE bar by S7, then yes, the WR bar pin, as you can see, the WR bar pin will come into the scene in memory write cycle, whereas in memory read cycle it will be RD bar pin. So in the memory write cycle, WR pin will go low during the T2 clock cycle, indicating that the memory that the microprocessor is going to transfer data or wants to write something into the memory. So DT by R bar signal will also remain same. Yes, DEN bar signal will go low during the T1 clock cycle only, which means that the microprocessor is ready to transfer the data. It is already having the data. So these two modifications, these are the two comparisons, or these are the two differences between the memory read and the memory write cycle. In the same way, your assignment will be to draw the time. These were the timing diagrams. So these were the timing diagrams for the bus cycle, for the 8086 bus cycle. That is timing diagram for 8086 memory read cycle in minimum mode, and this was timing diagram of 8086 for memory write cycle in minimum mode. Similarly, you can draw the timing diagram for 8086 microprocessor for input output read or input output write in minimum mode. So this was all about the bus cycle. I'm ending this class here. Thank you.